So this is my assignment 4.3.1 on data collection. So there are a number of different ways in which data can be collected. A research design is solely the type of study being conducted, for example experimental or cross-sectional, whereas a research method is actually what will be measured within the study. So for example measuring VO2 max in a young female Great British gymnast. So one type of study is a longitudinal study. This is an observational research method in which data is gathered around the same subject over a period of time. This can be conducted over years or even decades. For example, you could measure the effect of age on performance of young female Great British gymnasts. So, for example, you could perhaps measure the performance with a numerical value on these gymnasts from two different ages, so maybe from 10 years of age. Do this every 2 years, 12, 14, 16, 18, all the way up to 20, and just see how their performance changes over time. So advantages of this are it doesn't involve any interference with the subjects in the study, so they can essentially carry on in their natural environment. It's helpful in determining any patterns. There's more data over longer periods of time, providing more concise results so that they are more valid. And disadvantages is that this takes a very long time and requires a large sample. Next, there's case study. So this is an in-depth investigation of an individual, group, event, or community. So usually data is gathered from methods such as interviews and observations. So you can maybe take anthropometric figures for an under 18 female Great British gymnast. And anthropometric, if you don't know, is measuring the shape, size, and composition of the human body. So advantages of this are it produces rich data. A conclusion is formed at the end of the study explaining the findings. It provides unbiased introduction to case study, and results can also be used to improve lifestyles. So for example, the gymnasts could use their results to improve their physique and their diet perhaps. Disadvantages is that it could potentially be biased, so there's only one view from one researcher. Could also be quite time consuming to collect all the necessary data, and data isn't always able to be linked to the general public. Next, there is comparative studies. So this is research methodology collecting data that compares more than one thing. So you could measure and compare the sit and reach tests of young Great British gymnasts that are aged 10 and young female Great British gymnasts that are aged 15, for example, and compare the results. So this provides an advantage is that this provides a correct guide or template to understand in the other set of data. You can compare it to normative data, so you can see what is a particularly good result, what's an average result, maybe what's a poor result. You can compare the data to help rank others against each other, so see maybe who the best gymnasts are, who the ones who are not so good maybe. And a disadvantage, however, is that if perhaps a coach was to maybe compare to normative data, it could be biased because he wants to show that their gymnasts are of a very good standard maybe, when he could try and affect this a little bit maybe. Next, there's a correlational study. So this determines whether two variables are linked. So it aims to discover whether an increase or decrease in one particular variable will cause an increase or decrease in another one. So the effect that stretching has on British female athletes when performing floor. This determines whether there's a link between two variables. It allows the researcher to collect lots of data, much more than you would be able to with an experiment. Some studies also allow you to test for concurrent validity by comparing a new measure to an established measure. So for example, you could use correlational studies to determine whether the new BIA equipment is more effective than the older hydrodensitometry equipment in measuring body composition. Disadvantages, however, is that this only will uncover a relationship and won't provide any conclusion as to why, and it doesn't reveal which variable actually influences the other, so you're unsure of which certain variable causes the other one to change. Next, there's a cross-sectional study. So this is a descriptive observational study involving measuring different variables in the population of interest at one point in time. So the most important thing about this to note is that it's a snapshot of time. So it's one moment in time, one specific moment. It's taken from a sample population. So maybe you could measure the vertical jump tests of female Great British gymnasts aged under 10, under 12, under 14, under 16 and under 18. And the advantage is this is a very quick and easy way of amassing data. It's very cheap, and multiple variables at one time can be compared from the snapshot. Disadvantage is that it could be biased, again, because if the researcher wants to show a specific result, then there could be bias. They can't determine why it happens and what the effect is, and it can't be used to analyse behaviour over a period of time. An experimental study. So this is a procedure carried out to support and validate a hypothesis. They provide an insight into cause and effect by demonstrating what outcome occurs when a particular factor is manipulated. So maybe does a certain substance cause an increase in flexibility in the hamstrings of young female Great British gymnasts? Advantages are that this is straightforward and efficient. It's repeatable, so this makes the results reliable. The environment is controlled, so better results are achieved. However, it creates artificial situations, so making young gymnasts perform in a lab, which would be unnatural for them, and this could affect the results. It's very expensive, requires the use of a lab, and it can actually be subjective, and this can lead to potentially human error, and just this makes the results essentially invalid. So moving on, there's also primary data. So primary data is data that you obtain yourself, so you conduct the study. So for example, I could do a comparative study on the effect of consuming glucose on performance of young female Great British gymnasts. There are advantages to this. This is direct, it's tailored to current research, and it's reliable. And the disadvantages is that I could potentially be biased. I could want to show a certain thing. That I could want to show the glucose perhaps increases performance. It takes a long time consuming, because it's only me doing it, and it's expensive. There's secondary data on the other hand, which is data that you obtain from another source. So my friend could carry out a correlational study investigating the effect of stretching to see what effect this has on young female Great British gymnasts. I could use this as secondary data. So this is rapidly available because it's already been done by another individual. It's cheaper than primary data, and you get support with this. However, there might not be enough detail because it's from someone else, and the quality varies. So quantitative data. Quantitative data involves numerical data. It's objective, so it isn't based on feelings, it's based on stats and data. And for example, I could measure numerical data on the performance of young Great British gymnasts on floor. Qualitative data, on the other hand, is based on feelings and opinions. It's subjective, so yeah, essentially there's no numerical data, it's just how a certain individual feels about something. This can be collected through questionnaires or interviews. So I could observe some young female Great British gymnasts and then make a judgment on who I think is maybe of a good standard, who's the best, and who I think is the worst within gymnastics. So there are a number of classifications of data, and each of these have different levels of detail. So firstly, there's nominal data. This is when data is put into categories, and they are mutually exclusive, so the labels don't have any particular meaning. So this could literally be something as simple as whether young female Great British gymnasts have blue eyes or brown eyes. So this is very uninformative and not very detailed at all. So categories take on numerical data. So blue eyes could be labelled number 1 and brown eyes number 2. And this doesn't have any mathematical meaning. It's just simply labelling them a certain number. And discrete data is a form of nominal data also, where there are specifically just 2 categories. So for maybe whether female Great British gymnasts are right-handed or left-handed. Next, there's ordinal data. This is when categories are in an ordered sequence or rank order. However, the distance between those categories is unknown. So it could be known, for example, which young female Great British gymnast got the best score on balance beam, and maybe who got the second best score on balance beam. However, the difference between their scores is entirely unknown. So the numbers allocated to the categories do have a meaning, and this is more informative than nominal data. Moving on, there's interval data. So this is gradually increasing in detail. So interval data has a numerical scale with a meaningful order. The distance between each scale is equal. There is no meaningful zero, so this could be positive or negative values. So for example, temperature could be positive or negative, and it's more informative and useful than ordinal data. Lastly, there's ratio data. So this also has a numerical scale with equal distance between the scales. So it has a meaningful zero, meaning that all values are positive in this instance. All values are on a smooth scale. This is the most informative level of data, so the most detailed and essentially the most reliable and valid. And an example could be that you could measure the heart rate of young female Great British gymnasts before activity and after activity. So that's my assignment 4.3.1.